Alright, good morning. There are two objectives to today's lesson. The first one is to use an iterative formula to find a root of an equation to a prescribed degree of accuracy. That's the first objective. And the second objective is to identify an iteration which converges or diverges. So we will look at one question here first. Okay, we look at this question and then we will do the iteration, right, to find the root of the equations. And secondly, the second task later, we will see whether an iteration converges or diverges. Okay, so let's see the question. Okay, the roots of a function fx, x cubed minus 12x minus 5 are to be found numerically. It means you have to do numerical iteration. Okay, find them. Now, to do this numerically, we do a quick sketch first. Okay, try to sketch the cubic function. Okay, since the coefficient of x cubed is positive, that means the graph, right? The graph will be downward looking. Okay, concave downward and then followed by concave upward. Okay, there are three roots. Okay, you can easily check with your calculator what the roots are. Negative 3.233, positive 3.656, and negative 0.423. Right, those are the roots that you find through your calculator. But we want to do here, we want to do it numerically. Okay, using method of iteration. Formula 1, okay, rearranging the equation fx equals to 0, you have x cubed on the left hand side and 12x plus 5 on the right hand side. Okay, take cube root of both sides, so you have x equals to 12x plus 5 to the power of a third root, right? To the power of 1/3. The second formula that you can use, okay, by rearranging the equation, you have x equals to x cubed minus 5 divided by 12. Right? So those two formulas we're going to use now. Okay, MOI stand for method of iteration. Okay, let's look at the leftmost. Okay, so take the first formula. Okay, so now the formula of iteration is x sub n plus 1 equals to the cube root of 12 x sub n plus 5. Okay, let's use initial guess as 2, okay, x naught as 2. Punch in the numbers in your calculator. Okay, so x1 will be 12 times x naught, which is 2, plus 5, and then you take the cube root. Okay, save your answer in your calculator. Save x1 to be used in the second iteration. Okay, to get x2. So if you see here, x2 is 3.4724. Okay, same thing you do for x3, x4. The numbers are still changing, so you have to keep on iterating. Okay, until you get to the 9th and 10th iteration. Okay, see the iteration start changing, right? Especially especially up to the accuracy that you want, right? So if you want 6561, stop there. So seems that the sequence is converging to root that is 3.656. I would keep 3 decimal points. Yeah, there are 3 decimal places. That should be enough. 3.656. Okay, that's the first iteration, first set of iteration. Let's look at the second set of iteration using the second formula of MOI, x cubed minus 5 divided by 12. Let's start with the same initial guess as before. X naught equals to 2. Do the iterations. And it converges, right, fairly quickly, right, up to x4, the fourth iteration. Okay, will give you root of negative 0.423, right, the third decimal places. is 3, right? Okay, so that's the second set. And the last set, okay, we're going to use the first formula, except now the initial guess is -2. Okay, with initial guess of -2, you have iterations. Okay, started off with x1, -2.6684. Okay, quite long here, the iteration. Okay, I get up to the 10th iteration, 9 and 10th iteration, right? 9 and 10th iteration doesn't change that much, right? So you can conclude that the iteration converge to the root of -3.233. So this is basically, okay, the same as the 3 roots that we had gotten through calculator. Okay, so it should be correct. So what are the conclusions that you can take from here? Okay, I'm going to squeeze the conclusion here, right? From the 3 set of iterations that we have done so far, we can see that a different iterative formula with the same starting value can converge to a different root. Okay, let's check back here. Right? We started off with 2, first set and second set. Initial guess is 2, but the 2 sets converges to different roots. Alright? Same initial guess, but converge to different root. Okay? Then the second conclusion that we can make is that the same iterative formula with different starting point, different initial point, or different initial guess, different x0, can lead to a different root or even a diverging sequence. So we have been lucky so far. All our iterations have been converging to a root, but it may diverge, right? So let's look at the first and the third set of iteration. Okay, different set of, same formula of iteration, but different initial guess will give you different roots. Yeah. Okay, so the 2 conclusions, especially the second conclusion, we can see not all iteration converge, some diverge. So in order to avoid wasting time doing iteration, as you can see, doing iteration is not that easy. You have to keep punching your calculator, right? So instead of just simply doing iteration that may diverge, let's see if we can have the condition for iteration that can converge. Okay, so how do you determine whether a sequence converges or diverges? Okay, actually is by looking at the differentiation of the formula. Okay, differentiation of f, right? F prime of x, okay, add a value close enough to the root. Okay, the value of the differentiation has to be between -1 and 1. Okay, so if the value is between -1 and 1, the iteration converge. If it's outside that value, the iteration will diverge. Okay, let's try, see if it works. Okay, now fx. Okay, remember what is this? First formula or second formula? It's the second formula, right? Second formula of f, x cubed minus 5 divided by 12. Differentiate that, you get x squared over 4, right? Remember last time, in the previous page, we had used x0 as 2. Okay, we had used x0 as 2. So if we check the differentiation of f prime of 2 is actually 1. Okay, we use x0 2 or around 2, right? Okay, the value of the root is around 2, so 1 is well within the range of accepted, the range of f prime of alpha, right? So it's between -1 and 1. 2 is, the value that we use is around 2. Okay, so that's why it had worked. That's why it had converged to the root. Okay, if I let you see it again, yeah. Oopsie. Yeah, here. Okay, we had used x naught equals to 2 and the value actually converges. Yeah. But if we had used, let's say, if we had used x naught as a value that's far off, which is -4, okay, far off from 2, x naught equals to -4, f prime of -4 is 4, and 4 is outside the range of -1 and 1. Our iteration would have failed to converge. Okay, so let's confirm that. We use the same formula, x equals to x cubed minus 5 over 12. Use initial guess as -4. Punch in the numbers in your calculator and you will get x1 equals to -5.7, x2 equals to -16. Okay, x3 is even greater, -358. So as you can see here, right, the iteration actually diverges. Yeah, you wouldn't have gotten an answer out of the iteration. Alright, that's it. Thank you.